Hello friends, welcome back. Hearty welcome to you. Let us look at this problem related to inverse trigonometric functions. If cos inverse x by 2 plus cos inverse of y by 3 equal to alpha, then prove that 9x square minus 12xy cos alpha plus 4y square equal to 36 sin square alpha. So we have been given that cos inverse x by 2 plus cos inverse y by 3 equal to alpha. Then we have to prove that 9x square minus 12xy cos alpha plus 4y square equal to 36 sin square alpha. How to solve this problem? First, what we will do, as any regular inverse trigonometry function, cos inverse of x by 2 we will take it as an angle, let us say A, and cos inverse of y by 3 we will take an angle as B. Then we'll try to find out cos alpha, sin alpha, then we'll proceed from there. So let's go ahead and start. Let us say that cos inverse x by 2 equal to alpha and cos inverse y by 3 equal to B. Oh, we have alpha and beta already. So let's take something else. We said A plus B, so we'll take down A plus B is equal to alpha. So what's the meaning of that? We took cos inverse x by 2 equal to A. That means if I do the triangle for angle A, I will have cos A equal to x by 2. That means by Pythagoras theorem I will have square root of 4 minus x square here. Similarly, I can do the same thing for angle B. We know that cos B equal to y by 3. Y by 3. That means by Pythagoras theorem we have square root of 9 minus y square here. Now once the triangles are ready, we can start and we can find out cos alpha and sin alpha. So what we did, we'll write down here. We said cos inverse of x by 2 equal to A. That means cos A is equal to x by 2. Similarly, cos inverse of y by 3 is equal to B. That means cos of B is equal to y by 3. Now, let's first try to find out what is cos alpha. So we'll write down cos of A plus B is equal to cos alpha. That means cos A cos B minus sin A sin B is equal to cos alpha. What is cos A? We know that that is x by 2. What is cos B? We know that is y by 3 minus sin A. From the triangle we can see sin A is root of 4 minus x square divided by 2 into sin B. Sin B is opposite by hypotenuse, that is root of 9 minus y square by 3 is equal to cos alpha. So that's about cos alpha. Now let's try to find out what is sin alpha value. So for that we'll write down sin of A plus B is equal to sin alpha. Now why are we doing cos alpha sin alpha? Because what we need to prove, in that we see there is cos alpha and sin alpha and there is a sin square alpha, and you can see this is 36 sin square alpha. That means we have to find out sin alpha, then we have to square it up and we have to substitute some values from here so that we can get this equation. So let's write down what is sin of A plus B. Sin of A plus B is sin A cos B plus cos A into sin B equal to sin alpha. That's nothing but, we know sin A, we already have values here. Sin A is root of 4 minus x square by 2 and cos B is y by 3 plus cos A is x by 2 and sin B is root of 9 minus y square divided by 3, which is equal to sine alpha. Now what we will do, this 2 into 3, whatever we have in denominator, we will take it to that side. We get 6 sine alpha, then we square, we should get 36 sine square alpha. So let's write down next step. Our next step will be square root of 4 minus x square into y plus x into square root of 9 minus y square equal to 6 into sine alpha. Now in the next step, we'll square this up. Now let's try to square this equation, whatever we got here, so that we can get 36 sine square alpha. So when I square it up, what I will have? I will have, shall I write down one step where we say square root of 4 minus x square into y plus x into root of 9 minus y square is equal to 6 sine alpha. We want to square it on both sides. SOPs. Next step will be a plus b whole square formula. So a square plus b square plus 2ab. Can I write down 4 minus x square into y square plus x square into 9 minus y square plus 2ab term, that is 2xy into square root of 4 minus x square into square root of 9 minus y square is equal to 36 sine square alpha. We'll open the bracket and simplify. Let us see what we are getting now. We will have 4y square minus x square y square plus 9x square minus x square y square plus we have 2xy into root of 4 minus x square 9 minus y square. But in the what we need to prove, we have 12xy cos alpha. That means we have to replace this with the help of cos alpha formula and get into xy and cos alpha. So what we can write, square root of 4 minus x square into 9 minus y square, that is equal to, let's write down that. We can see that square root of 4 minus x square into 9 minus y square will be, first we can take 6 that side, you will have xy minus this equal to 6. So root of 4 minus x square into root of 9 minus y square equal to xy minus 6 cos alpha. So I can write down 2xy into xy minus 6 cos alpha is equal to 36 sine square alpha. So when we go to the next step, that will be the final. So 9x square as we need minus, let's write down plus 4y square, then we have minus 2x square y square, because we have minus x square y square minus x square y square. To cancel that out, we have here plus 2x square y square, then we have minus 12xy cos alpha is equal to 36 sine square alpha. So we can simplify that, we can cancel these two terms. We will have 9x square minus 12xy cos alpha plus 4y square is equal to 36 sine square alpha. So this is what we need to prove. So let's summarize this, how we did this problem. We have been given that cos inverse x by 2 plus cos inverse y by 3 equal to alpha. So we took cos inverse x by 2 as angle A. Cos inverse functions always return to us angle. So cos inverse y by 3 is B. Then we kept triangles for angle A and angle B, so that we know all trigonometric ratios of angle A and all trigonometric ratios of angle B. Since in the problem we see we have sine square alpha, what we have done, we found out what is cos of alpha and sine alpha by using the formula cos of A plus B is cos alpha and sine of A plus B equal to sine alpha. Now we took whatever we got from sine of a plus b equal to sine alpha, we squared it, and to simplify that we have used whatever we got from the cos alpha, cos of a plus b equal to cos alpha, and at the end we arrive at the solution, that is 9x square minus 12xy cos alpha plus 4y square equal to 36 sine square alpha. So that's one interesting example. I thought I'll share that with you. Please do let me know your feedback. Thanks for your time and support. Bye for now. Before signing off, let me tell you that we can solve this problem in another way also. That is, directly we just find out only cos alpha and we try to substitute and square it up. Let us see, that way also we can find it, and that is little bit easier than what we have done. So we'll look at that particular option also. We know now cos A is x by 2 and cos B equal to y by 3 minus sin A, that is root of 4 minus x square by 2, into sin B, that is square root of 9 minus y square by 3 equal to cos alpha. So we'll take 6 to that side and we'll write down 6 cos alpha equal to xy minus square root of 4 minus x square into square root of 9 minus y square. Or can I write it as xy minus 6 cos alpha is equal to square root of 4 minus x square into 9 minus y square. Now we simplify this. We actually square it on both sides. So then we will be getting within 2 steps the answer. Now let's square this on both sides. We do SOPs, squaring on both sides. We get a minus b whole square formula, that is x square plus y square minus 12xy cos alpha plus 36 cos square alpha is equal to, open the brackets, you will have 36 minus 4y square minus 9x square plus x square y square. X square y square, x square y square cancels. If you bring everything to left hand side, there you have your answer, 9x square plus 4y square minus 12xy cos alpha is equal to 36 minus 36 cos square alpha, which is nothing but equal to 36 sine square alpha. So there is another way you can do directly with cos also. So sometimes it may not strike you that you have to take cos alpha and square it. So what I have done, I have shown you both the methods. If you take sin alpha cos alpha and try to square sin alpha, or you take cos alpha and square the sin alpha, both the ways you will get the same answer. Thanks for your time and support. Bye for now, this time for real. I'll catch you once again with another interesting example. Till then, keep smiling and sharing. Bye.